Okay, so I think we've been talking a lot about data analytics and IoT and AI, I heard partially this morning. So I'm going to talk a little bit about what is this data? I mean, what is the nature of the data? And kind of try to address that what we knew about the data and how we designed either platforms or products or solutions. Maybe there's a, not maybe, there is a humongous change that is coming that is required for the IoT or the future of the data, because there are way more complexity and not only the complexity in the ecosystem, but also in terms of the kind of data and the amount of processing that you need to do. So getting into that, we all know that IoT is an ecosystem. Basically, there is a platform, there is an enabler where you're collecting the data. So, and it is kind of surrounded by, there are device manufacturers who are building all the sensors. Then there are applications provider. And of course, there is network connectivity. And then there are, there are other players in the marketplace who are providing numerous solutions, because when we talk about IoT, we are no more talking about one industry, two industry, manufacturing, automotive. It is actually all it's permeable everywhere. And having said that, just some numbers. I'm not a numbers person, but I'm going to kind of throw this because we have this data. So if you look at 2016, 43% of enterprises are currently adopting IoT. I think what I want to address is, if you look at the 2025, the global IoT economic impact is about 11,000 trillion dollars. And if you look at the bottom number, which is 5 million new IoT devices are connected daily. 5 million IoT devices are getting connected daily. So that is, it is not about just the device. Imagine if there are 5 million devices getting connected, the amount of the trillions of gigabytes and data that is getting generated through these sensors, and we have to make sense of it. So this is just the quantum. And again, some projections, and these have been anywhere if you go, you will find the same data appearing over and over and over again, 15 billion industry and consumer M2M and IoT devices. This is currently the situation. However, I'm going to show you another slide where it's changing very fast. So automotive, transport, utilities adopted IoT very fast, and some amount of security. However, what's going to happen is, if you look at the green bar, I don't know if it's very visible on the left-hand side, it is about, like about 20% adoption at this time today, standing today in 2018. Whereas you see the exponential growth that goes into almost 70% adoption by almost all industries. Now, what is the category of IoT spend here? We always think IoT, most of the time people talk about the infrastructure and the hardware. That's only constituting the 40%, and network, of course, which will stagnate after a while. It consists 50% of the total IoT spend today, and there's 50% of professional services and the platform services, which actually means that the more we go, the curve towards the software and professional services are going to be incrementally high, because you will be done with your communication platforms, you will be done with your sensor data, the sensors itself, and the next stage is where we are going to go into what's going to happen. What's IoT today? They are like single silos. I am an automotive manufacturing company. I want to, from the shop floor, a car comes in aided with my telematics, infotainment solutions, my theft and pilferage solutions, to some extent even alarm monitoring of my spare parts, all of that. and that's just one vertical I gave an example of, and that is how it's happening in silos. Smart cities, my road infrastructure, my intelligent transport system, my connected, again, very siloed. What's happening and what's going to happen, it's not going to happen. What is happening is all of this is going to be at a cross section. So everybody is talking, insurance companies, and as you rightly said, there is this wealth of data that is existing in what we call the non-traditional industries, where there is a lot of data mining on an individual that is happening, which becomes very valuable for other segments. I am a car buyer. My insurance profiling is very important for my insurer. So my driving is also very important for the city or the state. So, of course, I'm not going to harp on the cloud again, but that is exactly what is happening. So it is becoming an open architecture with cloudized, and with, we are delayering all the components where the logic, and of course with the aid of blockchain and all of that, there is going to be an enormous influx of cross-pollination that's going to happen between all these industries, and data sharing and knowledge. So that's where the complexity lies with the data, whether we call it big data, we call it analytics, AI, whatever we want to call it. But at the end of the day, the handling that amount of volume and the complexity is what's going to be the emerging area in the IoT. Data in the IoT space. So I think I'm just going to read out shared understanding of the situation of its users and their appliances. That's my everyday habit becomes very important to some business. How I use my electricity or how I consume electricity in my home automation solution will get connected to the grid. So that is what that is the data requirement, or the data analysis requirement that's going to be required. Having said that, let me just, so three, I wouldn't say three pillars, I'm just kind of divided it into three. So shared understanding of the situation as user and their appliances, platform architecture and pervasive communication networks to process and convey the contextual information to where it is relevant. I'm going to talk about this a little later in a greater detail. And the analytics tool, the kind of choices that we make in the analytics tool that we choose, that will aim at building this autonomous and smart behavior, not only for people, but for the appliances itself. So this is just a pictorial depiction of what I just spoke about. So if you look at that bottom where I have many small pictures, and just look at the number. I've not even represented the industries. If you look at the industries on top, I am just skimming the surface. If I write utilities, automotive, transportation, smart cities, shipping, it's nothing, actually. There is everybody. I mean, starting from agriculture to fishiculture to, name it. Everybody, anything. Smart manufacturing, everything is now driven by smart, intelligent devices, whether they are sensors, RFID chips, whatever it is, and that data giving me back the intelligence as to what I need to do. So in that, what becomes very important, of course, the insight, analytics, and the handling of the big data. And it becomes very important. Again, just a pictorial depiction, data is the driver. So that is a bus. That is actually a bus with no one in it. And it's completely being self-driven, and just a little plug for my company. So Ericsson is testing this in Stockholm. So there are buses running all across Stockholm without any drivers. So everything's just sensor-based. Again, this is now I'm kind of pushing a little bit into the analytics space. This is sort of the data. Again, it is IDC available. This is not my slide. So this is the kind of organization that is planning for the IoT. 79%, I mean, huge. What are the new demands from IoT? Actually, let's kind of split it up, and I'll tell you why I want to split it up, and that is because of the data asset that we have. One is the consumer IoT, where there are millions and millions of sensors that is getting at anything. Even a window pane today can come with a sensor. That becomes a sensing device. Even, I was just reading yesterday that in Japan, there is a little Band-Aid that has been, has been kind of invented with a chipset for monitoring the health of patients who cannot move around and, are old and need help. So it's like a Band-Aid you just put on your hand. So, and of course, we've heard about smart industries and smart cities and all of that. So there is this consumer segment with sensor data. Then we have another, which is the cellular, which is the social data that we are getting. So today when we talk about smart cities, it's not only about smart sewerage and smart lighting and smart traffic. It is now getting actuated with data coming from billions of probes in our social media. You talked about capturing the emotions, what exactly he was talking about, my previous speaker, about actuating that kind of a social emotion on top of, overlay on top of the data, what we call the functional and the non-functional data that is coming. That makes it more interesting, and that makes it more complex in order to provide a solution or a service. So different devices, different needs. Human-machine devices, which we are still using with our touch and fingers and stuff like that. And then there are embedded solutions, okay? So we have this data. We can leverage on this data. There is data there is about 10 billion. These are numbers I cannot vouch by. Again, these are numbers that I've taken from the net. So we have user data. We have 10 billion user data. We have 5.5 billion consumer IoT data. And we have 12.5 billion industry IoT data. All this data is available. We are sitting on data assets, and it is just kind of how we play it to build about the solutions for the industries. So unlocking that enriched data becomes very important. That's my first point. So we are sitting on data. Of course, we are going to generate more and more data. I'll come to that. How do we unlock the value of that data? Because out of the data that you have, 90% would be garbage for your usage. So you have to throw away 90% of that data. But what is that 10%? Identification of that 10% becomes very important. And that is where all the complex logic is going to come in. Then you use embedded user and IoT data analytics. IoT itself, the sensors itself are throwing a lot of data, right? And those data, they have their own complexities. There are critical data, high latency data. There are batch datas. So there is a lot of things, and each application is different. When I am doing a remote operation, I'm sitting in Chicago and I'm doing an eye operation through robotics hands, and I'm not talking about science fiction, this is true, in Chennai, then the critical data that is getting generated becomes very important. I don't know if you're aware, there is a lot of athletics performance initiatives that's happening through IoT data. And it's happening in this Olympics, the Winter Olympics, and there's going to be, in the Korea Olympics, there's going to be a huge, and we are actually right now field testing the cars, the car rally, the cars. We are building, the entire cars are getting powered by the sensors and the logic in there, where every inch of the car is getting a sensor to monitor all the thousands of parameters of the car. Even human, the angle at which you kick, the angle at which you bend your head, the angle that you're, the velocity in which you're kicking, all of that are being captured through, sensors built into socks, in your sneakers, in your helmets, in your pads, all over. So imagine the amount of data that is getting generated through that. So this is the embedded IoT part of it. And then the new value from the insights we get into it. At the end of the day, we know that we'll be able to collect that data and process that data if we have a huge enough infrastructure. So that is another challenge, the infrastructure, and hence, big data and those kinds of platforms. But what do we do with that data? The insight part becomes very important. Unless I'm able to enhance the performance of an athlete through those data and build that kind of analytics and KPIs and throw it back to them, there is no point in collecting that data. So what are the new demands? How am I doing? 6 minutes. Okay. Okay. So what are the new data demands from IoT? The physical world data and integrate it into the cyber and the social systems. Ability to continuously link, interpret, and share dynamic knowledge. That's very important. It's a very mobile data. It's every second, every minute, every microsecond, depending on what. If you are playing contact football, it is every second. If you are racing a car down in Grand Prix, it is every microsecond you need that data, and you need it to process very fast. Whereas in a CCTV or a surveillance kind of a thing, you can have a higher latency, you can tolerate a higher latency of data. So that becomes very important. Not only large in volume, but it is also multimodal, varies in quality, format, representation form, and level of dynamicity. Main difference between the sensory data streams compared to the conventional streams and data models will be rapid changes in the data and the dynamicity of the environment. Resource constraints in sensing platforms and distribution and heterogeneity of the data. Again, I am always giving almost one example. Imagine putting all of that together. So the heterogeneity of the data, you are getting some data from my body, sensors, my temperature, my pulse rate, and things like that, and then you're getting some other data from the football, which is being kicked, and the angle, and what is coming from there. So the heterogeneity of the data is exceptionally high, and then bringing it together. Efficient stream reasoning mechanisms are required to interpret the meaning of events in a context-aware fashion and share such meaning across applications. I think this is the principal challenge, is to make any of that data context-aware and meaningful to who and how the subject needs that data. So that is, we are not talking about static data where you have a lot of time to analyze somebody's behavior pattern. We are talking about micro and milliseconds where you have to make decisions. So that is the difference in the IoT data. Large number of M2M devices, sensors, actuators, gateway, I'm not even getting into that, and the data measurements will be a prime application requirement. Wide spectrum of data sets, scalable processing of high velocity data, and increasing capability to handle complex relationship to distinguish between key value stores, columnar store, I'm not going into all that detail, and handle data in motion. I think I've addressed that. So these are some of the key areas. Again, operating on very temporal window. Your window of decision making is very short. Even when we used to say real time also had some legacy. Today, when we say real-time data analytics, there is a predictive engine that has happened before with a certain amount of legacy data and historical data. When today we talk about real-time, it is temporal data. The window is very short. So that is another challenge that is coming up. Facilitating analysis over disparate sets of data, and it is understood that IoT applications vary in terms of data sets that they employ in their function. So that light is blinking, so I'm just going to contextualizing the physical phenomena by providing a subjective context, calibration of noisy events. Like I said, we have to throw away 90% of our data. Detection of below-the-radar events by combining both subjective and objective. Social media responses to, say there has been a traffic accident which requires the attention of the city, the police, the ambulance. Those are all, and that may be detected through the poles that have been set up. But then there are cars passing by who are adding comments while on the way. Now, overlaying those kinds of contextual data and what is the context and making meaningful sense of it, those are the tricky part, okay? So I think I'm done because the time is almost up. I have a very short video to play, but if there is no time, I'll not play. Okay, okay, I've just wrapped up and I'll just play this.